In episode 1, we demonstrated that, contrary to what Phil Webb and other propagandists have claimed, the Apollo samples do indeed contain water contents that are commensurate to their terrestrial cousins. We also proved that there could not possibly be water on the Moon, and the terrestrial contamination and comet impact excuses are pure ad hoc. Today, we will be looking into Phil Webb's video regarding chemical compositions, mineralogy, and oxygen isotope ratios of the Apollo samples and Earth rocks.
The foundation for Jarrah's claim that NASA's moon rocks actually originated from the Earth comes, of course, from the Bible according to Casing.
Actually, my foundation for the claim that Apollo samples originated from the Earth comes from the various testimonies and reports of scientists and geologists who say that the Apollo samples have a chemistry, mineralogy, and so forth identical to Earth rocks. Casing merely picked up on that info long before I did. Let's make a comparison. I'm sure you all remember the bucket of JSC-1A lunar regolith simulant that I purchased from Orbitech. On the company's website, we find two PDF files that tell us the chemical compositions of these simulants. One for JSC-1A and one for JSC-1AF, which make up the finer particles of the former. These simulants are basically crushed basalts that have been found on Earth.
As you come around there, there's a rock in the near field on this rim that has some white on the top of it. We'd like you to pick it up as a grab sample.
This one right here?
That's it.
This one right here?
That's it. You got it right there.
Okay, that's a football-sized rock. It's a great Scott size. Sure you want a rock that big, Houston?
The largest sample ever supposedly retrieved from the Moon on an Apollo mission was sample number 61016, more popularly known to the general public as Big Muley. If we look up NASA's geological analysis paper for this rock, which one can dig up on NASA's Lunar Sample Compendium website, we find a list of 3 tables categorizing Big Muley's chemical composition. One table for melt rock, one for anorthosite, and one for black glass. Broadly speaking, the chemical composition for Big Muley and Orbitech's Earth basalt-derived lunar regolith simulants are as follows. For example, for SiO2, Big Muley melt rock is 43.3% silicon dioxide, its anorthosite is 44.15% silicon dioxide, and its black glass is 44.48% silicon dioxide, whereas JSC-1A is 46.67% silicon dioxide, and JSC-1AF is 47.1% silicon dioxide. For Al2O3, Big Muley melt rock is 25.1% aluminium oxide, its anorthosite is 33.19% aluminium oxide, and its black glass is 29.83%. Whereas JSC-1A is 15.79% aluminium oxide, and JSC-1AF is 17.1% aluminium oxide. For CaO, Big Muley melt rock is 14.3% calcium oxide, its anorthosite is 18.3% calcium oxide, and its black glass is 15.64% calcium oxide. JSC-1A is 9.9% calcium oxide, and JSC-1AF is 10.3% calcium oxide. The similarities go on and on. The guys at Orbitech have clearly done their homework. And it's not just Big Muley that has similar chemical compositions to Earth basalts, it's moon rocks in general. We will be looking into the compositions of Earth rocks and Apollo samples a lot throughout this entire Moon Rocks Revisited series. But for now, here is one such comparison that was put together by the Smithsonian's Brian Mason and William Melson. In their studies, they compared the average compositions of Apollo 11 samples to the composition of a deep-sea basalt that Melson had personally studied in 1968. They also found that by subtracting 18% of the moon rock's ilmenite we get an even closer match between the two. As demonstrated on their chart, Apollo 11 samples are 49.71% silicon dioxide, deep-sea basalts are 49.21%. Apollo 11 samples are 11.61% aluminium oxide, deep-sea basalts are 15.81%. Apollo 11 samples are 13.62% ferrous oxide, deep-sea basalts are 8.18%. Apollo 11 samples are 8.86% magnesium oxide, sea basalts are 8.53%. Apollo 11 samples are 13.6% calcium oxide, deep-sea basalts are 11.14%. Apollo 11 samples are 0.57% sodium oxide, sea basalts are 2.71%. Apollo 11 samples are 0.21% potassium oxide, deep-sea basalts are 0.26%. Apollo 11 samples are 0.32% manganese oxide, sea basalts are 0.16%. Apollo 11 samples are 1.71% titanium oxide, sea basalts are 1.39%. And finally, both Apollo 11 samples and deep-sea basalts are 0.15% phosphorus pentoxide. Now you're probably saying, that is an unfair comparison, because you had to remove some of the ilmenite in order to get the normally high titanium Apollo 11 samples to match the relatively low titanium Earth basalts. It's a moot issue, because there are also high titanium terrestrial volcanic rocks, such as the titanium-rich deep-sea gabbro that Mason and Milson also compared. It's clear as day that it is a near-perfect chemical match all-round between the Apollo 11 rocks and high titanium gabbros. And it's not just these rocks that have almost the same chemical compositions as Earth rocks. There are many samples to choose from, but if you're lazy, don't worry, because Bazio and Ridsecker compiled together the average chemical compositions from each mission and put them all into one simple table. It's rather obvious when you pitch these numbers against the average compositions of the JSC-1 simulants, you get a remarkable correlation. In most cases, you don't even need to remove the ilmenite to make them match, as was the case with the titanium-rich Apollo 11 samples. The Apollo 11 samples are known for their high titanium contents. The samples from the other missions are generally low in titanium and thus a closer match in composition to the low titanium JSC-1 simulants. Now some propagandists are probably whinging that Fe2O3 or ferric iron oxide is listed in the JSC-1 composition table but absent in that of the lunar samples. It's a moot point, because as we discussed in episode 1, and as we'll discuss even further in episode 6, ferric iron oxide has been found in the Apollo samples. But like the water, it has generally been dismissed as terrestrial contamination. Right. Most likely, ferric iron is not included in these tables for that reason. That covers chemical compositions between Apollo samples and terrestrial rocks. As for their mineral composition, in the same paper, we find this table for the average minerals of samples from each landing site. A quick look reveals that the samples are either pyroxene or plagioclase feldspar, with the rest being olivine and opaques. According to Mason and Milson, the opaque minerals in question are usually ilmenite. I could not find a mineralogical composition table for their terrestrial counterparts, but an online 1994 paper by Dr. David McKay says this about the original JSC-1 simulants, also derived from crushed basalts.
The minerals found in JSC-1, plagioclase, pyroxene, olivine, ilmenite, and chromite, are also characteristic of many lunar basalts and mare soils. The compositional ranges of these lunar minerals generally overlap the ranges of their terrestrial counterparts.
Clearly, just as Bill Kaysing had been pointing out, the Apollo samples have virtually the same chemistry and mineralogy as terrestrial basalts. It's obviously not poisoning the well, as Webb alleges. Geologists have always known about the striking similarities to these rocks. This, combined with the alleged absence of water in the lunar materials, led scientists to outright accept William Hartmann's giant impact theory. But we know that the rocks do contain water, which calls into question that theory. The fact that moon rocks are very similar to Earth rocks was also taken into consideration by Bill Casey. As he states on page 10 of the Desert Publications issue of his book, of all the tasks undertaken to assure near success of the hoax, creation of believable rocks was the easiest. By their own admission, all rocks contained minerals common to Earth. In short, no real surprises at all.
The great Sensei Casing managed to trivialize the most compelling evidence that the Apollo missions were real by saying that faking believable moon rocks was the easiest thing to do. But he apparently gave no clue as to how it could be done. At least Jarrah doesn't reveal the details as to how Grandpa Casing would have gone about faking moon rocks. This is a bare assertion fallacy, implying something is true simply because the person saying it says it's true.
It's not a bare assertion fallacy. Casing specifically pointed out that the Apollo samples have minerals common to Earth, and that no whopping discoveries were found. Throughout my Exhibit D series, I provided God only knows how many interviews and snippets from books and papers that confirm the common characteristics between Apollo samples and Earth rocks. A bare assertion fallacy is when you state something as fact without providing any evidence for that statement. And there are mountains of sources that pick up on the similarities between Earth rocks and moon rocks. It's interesting to note, later on in his book, Casing pointed out that it had been predicted prior to Apollo that the moon rocks would be similar to Earth rocks, that the Apollo samples were, as he put it, made to order. His source of this information comes from this passage of the book, Journey to Tranquility. On page 162, the authors refer to a 1964 testimony by Dr. Philip Abelson, director of the Geological Laboratory of the Carnegie Institution of Washington and editor for Science, the journal for the American Institute for the Advancement of Science.
Abelson himself agreed and went on to outline the common reasons for the scientists' concern. Much, he said, was already known about the moon: its size, its weight, the density of its rocks. It was already certain that nothing of economic value would be brought back, nor any material which was dissimilar in composition from Earth rocks.
To which Casing concluded,
First, since no one had ever seen or handled a lunar material, whatever NASA chose to produce would become the standard. Second, NASA had the funds to employ top scientists to predict what kind of rocks and other materials might be expected to be found on the lunar surface. These predictions would be made from extrapolations of terrestrial geology and data from Surveyor, if indeed these really landed. Finally, by combining speculations with some hard knowledge, it would not have been difficult to transform various types of Earth rocks into lunar specimens. After all, the moon was most likely once a part of the Earth, and thus minerals would be similar.
We'll discuss the Surveyor data later on in this video. For now, let's have a look at the alleged differences between Earth rocks and moon rocks that Webb points to.